Hello mechatronics students, this is Andrew Dowlin, and in this video we're going to be talking about analog inputs, specifically to the PLC. So let's get into some of the details. First of all, the differences between an analog signal and a digital signal is that digital is going to be on and off, ones and zeros. Everything is encoded into binary numbers, and good examples of our discrete digital inputs and outputs have been what we've worked with so far, where you push a button and that Boolean data type goes from a 0 to a 1. That's a great example of a Boolean or a discrete bit in a PLC program. Likewise, on the output side, when we turned on and off a valve, that valve had two states, on and off, 0 and 1. So when the valve output was off, it did not advance, it did not move, just like, and when it's on, it would shift and cause the air cylinder to move up and down, or it would turn on the buzzer or the horn or whatever it was. So those are two states, on and off. The analog inputs, by contrast, they have many different states. And to take a peek at this, let's first look at one of the schematics for our analog inputs and go from there. So this is one of our schematics for the PLC trainers. And we can see this is our analog voltage input here, analog input voltage. These guys are designed to take in a 0 to 10 volt signal. And how we accomplish that based on our 24 volt supply is we run it through a little resistor network. And you can see we have a fixed resistor that's at 14 kiloohms, and then a potentiometer over here that's at 10 k ohms. And through the magic of voltage dividing, this 14 k ohm resistor should drop 14 volts. And the 10 should drop 10 volts, and 10 plus 14 would give us our 24 volts. Then we steal the wiper terminal from our potentiometers, and it goes to the IN0, or we have two channels on this particular one. So we have two potentiometers, and one of them feeds into analog input channel 0 and analog input channel 1. So let's take a peek at the actual devices here and do some voltage measurements. So we have our camera zoomed in on our analog input modules. This is the voltage one is in this slot, and then there's the current 4 to 20 milliamp. We'll talk about that later. And the resistors we were just talking about here are built into these terminal blocks. So this is the 14 k ohm resistor that's installed here. And if I were to measure, I've got this set up for voltage DC measurement. We should be dropping about 14 volts. It's showing 13.8 across each of these resistors. 13.8. The other 10 volts should be going to the input of this analog channel 0. So if I were to grab one lead and place that on a voltage negative, you can almost see it in the camera there, and then the other one, bring it to a test point. Let's see, I gotta find out where that channel connects to, and I'm not sure I can actually get my meter stabbed in there. Yes, I can. Okay. So I was able to gain access to it and touch the wires that are going into that channel from the potentiometer. And you can see as I rotate the knob, I've got the potentiometers here that are labeled 0 to 100, not visible on the screen, but as I rotate this upwards, I get numbers from 10.33 volts and all the way down to 0 volts. So, and it's variable based on the location of that potentiometer. So I should be getting that for both of the voltage inputs that are going into this module. So that's not a simple on and off state. That is a variable analog input signal that goes from 0 to 10 volts. So now let's take a look at the PLC and the tags that are built into this. So here's our PLC program. Any program that you guys have that has the hardware modules configured, we brought these expansion modules in, so I can click on them to show you their definition a little bit. This is the analog voltage. It's in slot number 2. It happens to be a 1734 IE2V, which is a 2-channel analog voltage input module. We'll revisit that in a bit here, but let's find that particular one. It said it was in slot number 2. So when you look at our numbers here, local 1 IO, that's the stuff that's built into the PLC itself, and in our case, channel 2 is going to be our input. So if we click on channel 2I, we can see this input data, channel 0 data. That particular piece is going to be our potentiometers. So I'm live and running in remote, so I can vary these numbers up and down. So it looks like in this case they're going from 0, and as I increment it, it goes all the way up to about 10,364. Interesting, that's about what the voltage was reading, about 10 point so many volts, 10.3-ish on the top end. So it's 10,364, representing 0 through 10 volts approximately. So this gets stored in an integer number, and an int can store numbers between negative 32,000 and positive 32,000 and change. Let's take a peek at an integer is comprised of 16 individual bits. So we can expand channel 0, and we can see the individual Boolean type bits that make up this integer. 16 of them are going to make up an integer. So as we rotate this, you'll see them individually changing states. If I grab the right one here. And if I bring this number down to 0, it's interesting. This is just counting in binary. So if I get this to crack open just a tiny bit to a number that's easily figured out in binary, well, it's toggling between 0 and 1. So the 0 bit represents number 1. This represents number 2, 3, and 4. So I'm sorry, 1s, 2s, 4s, 8s. So 8 plus 1, or plus 4 plus 2 plus 1 is going to give me 15. Another way to look at this is your Windows calculator. So to understand how binary numbers are done, if we switch it from what you may have as a standard calculator into the programming calculator, and then we can set some of these things up. There we go. If I put this on just a single word, which is going to be 16 bits shown across the bottom of the screen, and it gives me the decimal equivalent up here. So this is the ones. So if I have a, that would be bit 0. There's the 2's place, the 4's, and they just double from there. The 8's, 16's, 32, 64, 128, 256, 512, 1024, 2048, and so on. They just keep doubling in numbers. So if I wanted a expression in binary of the number, let's say, let's go with like 36, okay? Well, I'm going to need to have 4 added to that. So again, 1s, 2s, 4s, 8s, 16, 32. So 32 plus this 4 is going to give me 36. This programming calculator is useful for you guys just to experiment with and see how binary numbers and integers work. But as you can see, it's 16 bits that stores that number in our analog input. So that's pretty neat. Now, let's go back to that analog voltage module and do some configuring on this. So over here, we have a configuration tab that's a very useful piece where we can set up what the high and low limits of this are supposed to be. So you can scale it. A lot of your analog input numbers, we don't care that it's 0 to 10 volts. In our case, maybe we care that the dial goes from 0 to 100, okay? Because that's the numbers that are shown on our actual dials, and then our variables could match that. So, but we could scale it to anything. You know, maybe it's 0 to 212 degrees if we have a temperature sensor on there, and it reads up to the boiling point of water. So we could set our engineering units from 0 to 212. So on channel 0, let's go ahead and set this up to 100. And I'm just going to go ahead and apply that. Yep. And then when we go back into our tags, controller tags, so channel 0 was set to 100 instead of 10,000. So now as I rotate my knob on there, it doesn't go, the highest number I get in this case is 104. So, and just like we were getting some overages when it was set here too, but that's a neat thing that we can change the scale of the analog input very easily in this software so that it goes to whatever numbers you want it to be. So let's go back to that channel module properties. And let's, the other example I said was, well, maybe at the high end of the sensor is 212 to represent actual degrees Fahrenheit or something of that nature. So I'll click on that and then go back to my tags. And then you can see that it's changed the units. So now the top end of this, I'm getting close to that 212 that was originally issued. So other things we can do within this module would be to set up alarms. And there are a number of bits that are associated with the alarms inside of the analog inputs. Very useful things. So let's get into this. It has 4 different alarms for each channel. Channel 0, we've got high, 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 and a low low alarm. And we can initiate these for each channel. So back in our configuration, we had put channel 0 at 0 to 100. So let's change the alarms up and say the high, high alarm is at 90. The high alarm is at 85, and maybe this is some sort of temperature or, what have you. The low alarm would be maybe 70, and the low, low alarm is at 65. Okay, so that should be, once I hit apply, yep, do your job. And now let's take a look at the tags and see if we can't find the different alarms, the process alarms for these tags. So here's the inputs associated with that channel 2. And let's see, do they have the actual alarms that go along with it? All right, so I'm looking at channel 0. And these are some of the alarms. So right now it's at 104. We should be triggering the high, high alarm is on, and the high alarm should also be on. Okay, so those are both set to 1. Now, if this variable drops below 100 for that channel, oh, there we go. I was off in doing some odd things there. Okay, so we said that the high, high alarm was going to go off at 90, so that's on already. Okay, now if this input drops below 90, 93, 92, 91. There it went below 90, or it's at 90. So the high alarm has turned off. But the high alarm is still in the on state. That's this guy here. And if we continue dropping below 85, that's where its threshold was at. So now all of the alarm bits have turned off. Then on the low side, the low side of the alarm limits, I guess we'll find out where they were set. I think it was 70 degrees, or 70, the number 70. There's the low alarm just went off here at 60, yeah, it's at 68. And if we drop below 65, we should then also see the low alarm triggered over here. So those are bits that we can use inside of our program to, well, to do whatever you want. They're programmable. So if this was a pressure thing controlling an air compressor, something like that, we could turn on the compressor if the pressure drops below a certain point, and then turn off the compressor once it gets to the high alarm. Those are just some good examples of what these alarms could do inside of our programs. So that's a pretty good deal. Now, if we were to use this inside of our main program, there's a couple things. I'm going to go offline for a second. And maybe we wanted to trigger some external things that would happen in the event of an alarm. So let me just create a new rung. I'll just throw that right up at the very top of this. That'll be just fine. So we can use those alarms to trigger different outputs. So as an example here, those bits are accessible, so we can come in here and find channel 2. And sometimes you got to find these buggers, right? So those are the alarm limits. I think I'm in the wrong side of things here. So I want to find the channel 2 input stuff. Okay. Okay. So let's say that we were to reach the high alarm for channel 0. That's this one, channel 0, high alarm. I can use that bit to trigger different things, and I need to take a peek at some of my outputs, but I think like the green light is input number 0. I don't have the template on here, so let's go to the local inputs and just grab something real quick here. Or, I'm sorry, the outputs. Want to make something happen, you got to use an output. Okay, so there we go. And that's how we could use one of the alarms to trigger something else. It's very, very simple. And we'll get into some other details with the analogs here in a moment. But if we were to download and run this, once that high alarm is triggered, it should then trigger that alarm over there, or that light. Just going to give it a download and demonstrate on the screen. It's pretty self-explanatory, but it's interesting that you can use these alarm bits to do different things. So, okay, the alarm bit is in the off state right now, but if we crank up the potentiometer so it reads over 90, whatever that high alarm is set for, it would trigger that bit, and away we go. So those are very useful to be able to use those alarms. Now, let's talk a little bit about how we could display some of this information and maybe even set and use some of those alarms in the panel view. So we could go and think about that. We could actually use the panel view to enter in what is the alarm going to be at, you know, what temperature or whatever. It could be a variable thing. Hit on the panel view screen, and then have that alarm show up. We could even show the numeric data inside of the panel view so you can see what your numbers are actually doing. And there's a few different things we can do inside the panel view. So let's get into some of those pieces here. So I've got this screen panel view thing. I'm just going to go to my main display for the time being. And let's get some numeric data to show up over here. And that'll come from our panel view. So numeric display. So if I wanted to just show what the channel 0 is doing, I can go to my connections, and I believe I can access all of these things and say, okay, refresh my folders. This is already set up from a previous program. So if I go into my local 2, there we go. I can see all of these things. And I think it was the local 2I that I was interested in. So I would like to see what channel, gotta find the right numbers here. Channel 0 data. That's the one I was interested in looking at here. So channel 0 data should be the actual stuff in there, the actual numbers. And I can make that show up bigger, things like that. So it's nice, good size. Hit apply. And okay, so that should all be it takes to get that number to show up. And if I wanted to be able to edit the high limits and whatnot of this, I can go in and put in a numeric input enable screen, or a little button in here. Numeric input enable, and I'm going to link this to one of the high tags. So the tag that's in here, I just got to do some searching for it. Find channel 0's high limit, and maybe that's under the channel 2 control. Is that what this guy is? Yes. These are my alarm limits, and here's channel 0 high limit I'm looking for. So there we go, channel 0 high alarm limit. And I can tell it that it's going to be a number between 0 and 100. And even in the label, I can show what it's at. So that's kind of a neat thing. I'm going to call it the text high limit. And then I can go to the next line and I'll insert a variable. And I can pull that from that tag list as well. So hopefully I can find that same channel 0 high limit on the output under the control tabs here. Channel 0 high alarm limit. So I should be able to edit that, and it'll even show up as a variable over here. Again, let's make it a little bit larger to be able to see it nicely. Hit OK. So with this particular one will show me what the alarm is, or what the actual channel is reading. And this one is going to show me the high limit alarm, and I should be able to edit that. So let's go ahead and test the application. And it'll probably ask me, do you want to save it? Yeah, do the saving thing. I think it's still doing its compiling. There was a different error message there. So we'll sit tight. Maybe not. Yeah, I had to restart it for some reason. I'll pay more attention to what error message popped up this time around. Starting the application. So again, we should be able to see a screen where I can edit the high limits and I can display what that channel is doing. So there we go. I can see the numbers moving around from as I rotate the potentiometer. Just grabbing that analog variable. And then my high limit is something that's adjustable here by clicking on this, and I can enter values between 0 and 100. So if I set my high limit to 40, then the variable should adjust. There we go. And that light that I have programmed should then turn off once it hits 40. Should turn on when it hits 40 and above. So I'm curious if that's going right into my variable. So that high limit 40, I want to go back to my program and tags and see, is that adjusting inside of here. So the alarm limit, channel 0 alarm limit, that's the low, there's the high. So it did adjust the number to 40 based on the application. And if I come over here and edit this down or up to 90 again, takes a second to update. And then when I go back in here, I can see that it did. So I'm directly accessing those tags and I'm able to mess around with the alarms. Okay, that's very cool. Now, this video is getting to be a little bit long-winded, so I want to show one more little thing on the panel view side of what we can do with some of these alarms. So let's get into, in addition to showing the numeric display, we have some graphical things that we can do as well, where we can bring in some bar graphs and even some data logging things over here. So let's, I'm going to bring in a gauge, and we'll have that connected to that channel 0. So this guy, I got to find the input side of it, channel 0 data, and it's going to display 0 to 100, so that's perfect. We can have a cute little gauge over here, and you could play around with the formatting on that. And also, we can take a look at trending stuff, which is kind of interesting to put a plot in here to trend the data. And I can go into, again, connections and say, I'm going to have multiple pens on this thing, but I'm just going to hook it up into that channel 2 data, or channel 0 data again for pen number 1, and hit apply on this. And this is kind of neat because it gives us like a running graph of the data as it's happening. So again, just going to test this application real quick, and then we'll conclude this video. So it's neat to be able to see the graphical data, the trends, variables going up and down, especially if you're monitoring, a lot of these analog inputs are monitoring things like temperature and pressure, distances. There's so many different types of sensors that could interface with this. So there we go. We can see our graphs are updating here, so I'm going to rotate that analog input. The bar graph moves, and I think the scale on the trend line tends to move up and down. Let it run for a little bit of time here, and then we'll start swinging it back up. So it's kind of neat to watch the pens plot across there. And again, so many different variables that we could have. Temperature, humidity, barometric pressure, just an infinite variety of things that could be plotted in here. So, like I said, I was running a bit long on this video, so here we go. We're going to wrap this up, but that's basics of analog inputs and what some of the different things that we can do with the alarms, some of the different things we can do with those variables, and showing information through that panel view. So that'll do for now, and we'll catch you guys next time. Thanks.